Welcome to our video on the cross product. This is really important for the calculus part of multivariable calculus, so we don't really do any calculus here, but we are setting up for it. Cross product is when we have two vectors and we cross them. Yeah, that's what that is. I'll explain that more as kind of go through here. Do recall though from AP Pre-Calc Unit 4, if you did that, you would know that the determinant of a 2x2 matrix would be if you multiply the diagonals and subtract the first diagonal by the second one, so it's to be AD minus BC. So that was for a 2x2. What we're going to do for a cross is we're going to find the determinant of a 3x3, whereas the first vector is the unit vector ijk, and then you're going to take your two vectors in the next rows and cross them. So if you have V is AI plus BJ plus CK, where W is DI and EJ and FK, so you can just fill in the blanks right there. Then we have V cross W. If you notice, I'm setting this up with the top row is the unit vector IJK, the middle row right here is just V, the bottom row right here is W. What that does is it makes us, and I'll show you using highlighters. If I can find, there's a highlighter. I'll do green. So if we're doing just the I, we're going to do the determinant of this right here. So you can kind of see that we're going to do B times F minus E times C with the I. And then when I do the J, I'm kind of using the opposite parts. And actually, I will erase. See you later, green. And then for the J, I'm just going to do this determinant, so I'm going to have AF and then DC. If you notice when I do J though, I'm subtracting. Every other one I change signs on. So the I is positive, the J is negative, the K is positive. If there was the next letter, L, that would be a minus, but we don't do that. And then for the K, if I were to, offline mode. If I were to, there we go. I don't know, red for K. K would be this determinant right here for AE and then BD. So it all comes out right here. And the whole point of the crossing of these is that we get a orthogonal vector. So when we cross V and W, we do get an orthogonal vector to both V and W. So before we get to the geometric properties and everything like that, and really algebraic properties, we're just going to practice finding these crosses. So let's go ahead, and this is very meticulous. I'm going to go towards these kind of slow and make sure I don't mess up here, because I'm prone to make lots of errors. On video, I make more errors than I do not on video. So just setting this up for V cross W. Take my V in the middle row and go 2, negative 1, 1, and then for W, we're going to go 4, 2, negative 1. Okay, and I am going to set this up and say for the I vector, I'm going to get, if I were to highlight these, that's my determinant. I don't know why I double highlighted there. So I'm going to go negative 1 times negative 1, which is 1. Minus 2 times 1, which is 2. Just double checking my work here. Yep, that's what I got. And then let's go ahead and erase what I just did here. And let's go ahead and highlight the next one. So this is going to be J. So minus something, something, J. I'm going to go 2 times 1, which is 2. Minus 4 times 1, which is 4. Plus something, something in the K direction. Erase these. And I'll do this in red. And then here is the K direction. So I'm going to get 2 times 2, which is 4, minus 4 times negative 1, which is negative 4, so plus 4. So I'm going to get negative I minus, so plus 2J. Plus 8K. Is that right? Oh, I feel like there should be a negative 2 right here. Oh, there should be a negative 2 right here. I missed that the whole time. See, I'm not really good with numbers. That's going to give me a positive 6. go with numbers. I just teach calculus. Hey, there's not much adding and subtracting in calculus, all right? So there we go. Let's go ahead and find W cross V. When I do that, I'm going to discover, wait, is V cross W and W cross V the same thing? Are they? No, I'm like seriously asking you, are they? What do you think? We want to predict that? So we're just going to change up the order here. Are you still thinking about it? Alright. Here we go. So I don't need to divisible anymore. I'm going to get 2 minus 1 I minus, still messing up, I'm not even doing every little step. Minus for J is going to be 4 times 1, which is 4 minus negative 2. J plus for K, negative 4 minus 4. Okay. So this is going to give me, oh, it looks super similar. But yet not at all. It's actually the complete opposite direction. So it's just the other direction of the orthogonal. And then we got V cross V. What do you think happens with V cross V? Any predictions here? No predictions? Oh, you probably are predicting. I just can't hear you. I forget that that's part of the video process, is you can't hear other people talk. What's that? Oh, wait, no, I still can't hear you. So when I do I, I'm going to get negative 1 minus negative 1. I, uh-oh. Minus, when I do J, I'm going to get 2 minus 2. Uh-oh. Plus, when I do K, I'm going to get negative 2 plus 2. Okay. That's actually going to give me no I plus no J plus no K. That's actually known as the 0 vector. So I'm going to put a 0 with a little vector over it. That is our 0 vector. So if you cross yourself, unless it's just a big old coinkydink, when you cross yourself, you get the 0 vector. Let's go ahead and look at our algebraic and our geometric properties here. So we look up at our green box, we can see our algebraic properties of that. If you do cross two vectors, it's going to be the opposite signs if you were to switch the order. So order does matter. Kind of see our distribution property there for 2. We can multiply by a scalar value, it's not going to affect anything. If you cross by a 0 vector, you will end up with a 0 vector. If you cross itself, you end up with a 0 vector. And then if you do a dot within these, if you have 3 vectors and you dot one of them, you can really dot any which one, you'll get the same thing. Geometric, though, is probably a little bit more important for us. You're going to get orthogonal vectors. If you remember from our last video, orthogonal is the word that means like perpendicular, but we don't use perpendicular for 3 dimensions, so we just call it orthogonal. Forms a 90-degree angle for each vector. If you do the length of the cross, you're actually going to get the length of u, length of v, sine of theta, which is a nice little property right there. If you do cross 2 vectors, you will get the area of a parallelogram. If you do cross 2 vectors, you get 0. They are parallel. That means they're going to be in the same direction. Oh, wow. I have no clue why the light just turned off. Well, you got me in the dark. And then if you take the absolute value of u dot crossing these vectors, you have 3 vectors, you're crossing 2 of them, and then you're dotting the other one, you're going to get the volume of a parallelepiped, which is a figure, which is actually down here. So example 2, let's find a vector that's orthogonal to these 2 vectors. So all that is asking is saying to cross these. So if you need to cross V and W, that's all it's saying. So I'm going to real quickly set this up. Maybe you should try this out on your own and see how you are at this, because I know how I am. I'm spotty at best. Oh, the light's turned off. I can't even see my answer. So when you do this, I will get an answer of, I'll do it in my head real quick, 1 minus 2, so negative I, minus, plus 4, because it's going to change signs, yeah, plus 4j, 4 minus negative 2 plus 6k. That's what I got. Is that what you got too? That's fantastic. It's great. I'm so proud of you. Let's go ahead and find the volume of this parallelepiped, which we know the formula right up here is the absolute value of u dot v cross w. So I can actually write these out as vectors pretty easily because these points are coming from the origin. So u is going to be 3, negative 5, 1. V is going to be 0 to negative 2. And W is going to be 3, 1, 1. And if you notice, the shape of a parallel pipette is really just like a box of some sort. It just kind of got kicked over a little bit. So when we do the volume, which is going to be the absolute value of U dot V cross W, since we're dotting this, we're going to dot the unit vector ijk, and we're going to end up with the determinant. Instead of ijk up along the top, we can just put 3, negative 5, and 1 out along the top. So we're going to get this right here. Okay, so I'm going to get 3 times 4, that looks like. So I'm going to check my math on that one. Minus a negative 5, so I'm going to say plus 5 times 0 minus negative 6, that's a positive 6. Plus 1 minus 1 times 0 minus 6, so it's going to turn into negative 6. Absolute value of that is going to end up giving me 36, so units cubed, sure. So there you go, there's our volume of a parallel pipette. Let's come down here to angular velocity. This is a rough one to kind of know. The velocity is tangent to the circle of motion, so we have this object right here which is going around and around. Okay, so we're trying to find the object at the at this point, just at some point on the circle that's going around and around. And so that velocity is actually going this way at this exact moment. Okay, and so a couple of things here within this picture is that this is going to be the length of r times sine right across right there. R is going to kind of looks like a hypotenuse here. And then we have the angle between where we're the rigid body rotating around. So we conclude that we have omega across r. The length of that is going to be the length of omega, length of r, sine of v, sine theta, which is going to give us our length of v right here. And we get that consequence from right here, from property number 2 for the geometric properties. Okay, so within that, we can conclude that if we're not looking at lengths anymore, that v is equal to omega cross r. So we're going to go ahead and work on this problem now. All right, so to get this to example, people keep walking across right here. I don't know, I have not turned the lights on yet. I've actually stopped this video a couple times in between. I haven't yet to turn the lights on. People are walking across. We're actually in the middle of a storm right now, and the power went out, and the lights were on, and then they weren't. So anyway, we have a rigid body here that rotates. The constant angular speed of omega, so omega radians per second in the direction of 2, 1, 2. Find the speed of the object of this body at the instant the object passes through the point 1, 3, 5. So essentially, if we're looking at this right here, this is going in the right here around omega at some speed. We don't really know what that is. And then we're going in the direction here of u. All right, I'm just going to call it u, into there. So this is what we're going to do. To find our omega vector. It's not w, it's omega. And I'm really bad at drawing Greek letters. It's just going to be some constant omega dot u. So u is going to be our unit vector. Of this right here, by the way. So unit vector of this rotating body. So if I take the length of 2, 1, 2, it's going to be 2 squared plus 1 squared plus 2 squared, which is 3. So this is actually going to turn into an omega is going to be 2/3 times this all. Sorry, not 2/3. Divide everything by 3. So we're going to get 2/3. I was writing that, said 2/3. 2/3, 1/3, 2/3. Okay, so that's omega. One down. Okay. Now for r, that's going to be our point where that happens. So we have r. So if we're going from the origin here, we'll just call this 1, 3, 5. So we need to find v, which is omega cross r. And really, I'm just going to save you the headache of watching me do arithmetic with fractions. and maybe keep my the respect that you may have for me. And I'm gonna just tell you what the answer is right here. Within these, omega. Oh, one thing I forgot about the omega is I don't have these values. So actually, this should be an omega right here. Omega. These are actually, we don't have omega values. So when I cross these, I messed up a little bit here. It's all right. I could edit that out, but I won't. It's too much work. It's an omega, not a W. There we go. So when I cross these, I'm just going to tell you what I get, just to save face here. Negative omega over 3. It's dark, I can't even read. Negative 8 omega over 3. I hope this is right. If not, you will tell me in the comments, right? You'll tell me. Yeah, so that's V. So we got V. It's kind of weird, right? So V is this vector right here. If it wants the speed of this, I just need to find the length of V. So the length of V is going to be square root of negative omega over 3 squared plus negative 8 omega over 3 squared plus 5 omega over 3 squared. When I do that, can we just agree with my math here? It's root 10 times omega units. Well, I can't write the word units. Units per what is it, second? Yeah, per second. All right, and there's angular velocity. There you go.